Creepy crawly juice is keeping the exploration world in tension after the red supermonster stood out in later years with outrageous variances and brilliance. A few specialists believe that the dangerous end of the heavenly mammoth was inevitable, but now the right shoulder of Orion is indeed creating a ruckus. On one hand, there is the hypothesis that Betelgeuse is rotating a lot quicker than it ought to because it once ate up another star. On the other hand, there is the presumption that the heavenly monster is still not alone. But even if Betelgeuse is truly a binary star, how could it be that the companion star has not yet been found? And how would its presence lead directly to the arrangement of a crucial mystery in our imagination? The sun often represents the extreme in the universe. No wonder, since in principle our Earth would fit into our strong mother star around 1.3 million times. And although the Sun, with a diameter of nearly 1.4 million kilometers, can confidently be described as amazing, we shouldn't forget that there are far larger celestial bodies out there that would transform our central star into a tiny dust molecule. So, a quick rude awakening brings us back to reasonable terms of cosmic realities, and that's when we understand that Betelgeuse bests the Sun in every possible way. Situated around 650 light-years from us in the Orion star grouping, this red supergiant's width is multiple times bigger than that of the Sun. This colossal contrast in size is also reflected in terms of brightness. In fact, Betelgeuse shines a walloping multiple times more brightly in visible light than our wellspring of warmth and life. Well, even in space research, the principle evidently applies that exceptions confirm the rule. As a result, years ago, Betelgeuse presented scientists with a huge mystery when it suddenly lost brilliance within a matter of weeks. In fact, the heavenly darkening was so pronounced that it could be seen with the unaided eye in the night sky. On a basic level, intermittent brightness changes are quite normal for supergiant stars, but in this case, it darkened much faster and more intensely than usual. A short aside, the cosmic unit of magnitude shows the apparent brightness of a celestial body, and the smaller the scale value, the brighter the object appears to us. While Betelgeuse, with an average magnitude of 0.3 to 0.4, is actually one of the 6th to 7th most brilliant stars in the entire sky. In December 2019 it dimmed to 1.1289 magnitudes and thus fell to 21st place in the brightness table. Is Betelgeuse going to turn into a supernova? As a result, specialists had to search for explanations for this unexpected development. Since Betelgeuse, as a red supergiant, is approaching the end of its heavenly life, at least the suspicion was briefly raised that its brightness drop was associated with an impending supernova. And we recall that when it is not experiencing strange darkening, Betelgeuse currently shines multiple times more brightly than the Sun. Anyway, when it says goodbye to the vast stage in a fierce blast, specialists anticipate that it will experience a 16,000-fold increase in its current brightness during this event. Betelgeuse would reach an apparent brightness of -9.5 to -1.5 magnitudes. Some scientists believe that the heavenly body will then appear as bright as the full moon, and it should even be easily visible during the day. But when exactly we can expect this brilliant scene is another matter entirely. In fact, most specialists have now abandoned the assumption that the supernova will happen in the foreseeable future. What was sometimes interpreted as a harbinger of a catastrophic event turned out to be a huge plasma ejection. In the course of follow-up observations, this created a no less significant dust cloud, which obscured the star by nearly 2/3 for our naked eye. As mentioned before, Betelgeuse has reached the final stages of its life cycle and regularly loses large amounts of heavenly material. This is moved to the surface by convection flows from the inside and ejected. Yet, in the same breath, Betelgeuse also experiences multi-day patterns of expansion and contraction. Scientists estimate that it was the combination of these intense forces and expansion that caused the plasma ejection to be several times more intense than expected. If we draw a comparison with the Sun, we see that Betelgeuse is also ahead in this case. The rate of mass loss during this event was about 30 times higher than for our Sun. Most importantly, the ejected plasma is likely to have cooled in space and eventually condensed into a massive dust cloud. Since this turned out to be in the line of sight between the Earth and the red supergiant, It appeared to us as an immense cloak that obscured the star. The rotation puzzle has Betelgeuse gobbling up another star, yet Betelgeuse wouldn't be Betelgeuse if it didn't have a few more mysteries for astronomers to solve. For example, pictures taken by the coupled radio telescopes of the ALMA observatory a few months ago suggested that it is rotating at a crazy speed. For a red supergiant, the rotational speed is more than 5 kilometers per second, which is 3 times higher than would be expected for a representative of this stellar class. In this context, Betelgeuse completely turns the heavenly scheme on its head. Stars generally tend to slow down as they expand. In this respect, Jings Ma from the Max Planck Institute for Astronomy in Garching, Bavaria, points out that Betelgeuse is actually the only known red supergiant that is believed to rotate so rapidly. More specifically, the corresponding speed is attributed to the bipolar structure of the surface. While one half of it shows a blue shift, the other exhibits a red shift of several kilometers per second. But what explanations do astronomers have for this astonishing rotational behavior? Most definitely, the first hypothesis is based on the understanding that Betelgeuse is a huge barbarian. In other words, when it ventured into a supergiant phase quite a while back, it may have swallowed a companion star like the Sun. In this case, the assimilation of such a star caused the swallowed star to transfer the precise momentum of its orbit to the outer shell of Betelgeuse, thus speeding up its rotation. While this theory was scrutinized in a computer model, compelling evidence for it has also been gathered. Pictures taken by the Hubble Space Telescope some time ago showed that 2 regions of ejected heavenly material lay dormant on one side of the supergiant. Essentially, these shell-shaped structures were interpreted as the harbingers of the coming supernova blast. Yet, they are found precisely at the distance at which they would be expected after a stellar cannibalism event. And although there are other possible explanations, Mama's research group brings up that the surface of the star is decorated with monstrous air pockets of rising and falling plasma that can cover a huge piece of its apparent external shell. That is exactly the vital point, since the quick development of these plasma air pockets can also deliver the previously mentioned red and blue shift of the radio discharge. As such, it is conceivable that insect juice isn't, as a matter of fact, rotating excessively quickly, but rather that it's creating a sort of optical illusion. If an exceptionally large convection bubble, or a group of them, is moving towards the observer and another is escaping from him simultaneously, indeed, even a star that isn't turning in any way can seem, by all appearances, to be turning very quickly. What's more, to be sure, a new examination of the ALMA data, in combination with an astrophysical model, showed that this explanation is everything but outlandish. In fact, according to Mama, there is a 90% chance that the guides created in the simulation will be mistakenly interpreted as high rotation rates. This is fundamentally because of the low resolution of the ALMA images, which distorts the true characteristics of the movements on the stellar surface. So, at present, it's unrealistic to say with absolute certainty how fast Betelgeuse truly turns and how probable the situation of the swallowed star is. However, what we can say is that the evidence is mounting that the red supergiant isn't alone. Later, does Betelgeuse have a companion star? As mentioned before, the brightness and surface of Betelgeuse throb in a pattern of around 400 days. Well, as a matter of fact, the red supergiant has still not recovered from the massive plasma emission of 2019, and the resonations of the emission continue to make quick motions in its interior, while the surface is still vibrating like an oversized jam. According to space experts, it will require quite a while before the star finds its way back to its generally expected rhythm. Anyway, notwithstanding its 400-day throb, Creepy Crawly Squeeze also shows an additional, longer brightness variation that happens over a period of 2,170 days or nearly 6 years. However, the explanations for these long periodic fluctuations remained unclear for a long time. To change this, Jared Goldberg and his associates from the New York-based Flatiron Institute recently dedicated themselves to the task of completely re-evaluating all of the observational data on Betelgeuse. And indeed, the new investigation uncovered a number of startling oddities. These start with the way that the 6-year cycle in the star's light curve is dependent upon an unexpected phase in comparison to the subtle multi-day throbs. In detail, the long periodic fluctuations are shifted against the musical throb. Past that, however, the specialists could not register any accompanying peculiarities that would be related to causes, such as rotation sequences, magnetic field effects, or convection flows. Eventually, the specialists came to the conclusion that there is only one possible explanation for the long-period motions that has no major flaws, specifically, the presence of a smaller companion star. In other words, the unusual 6-year variations would, therefore, reflect the orbits of the companion star. When the stellar companion is behind creepy crawly juice, as seen from Earth, the secondary period is at its lowest brightness. However, when the companion is close to Betelgeuse, the light of the two celestial bodies combine, and the brightness reaches its maximum. Simultaneously, the companion star could also act as a natural dust shifter, affecting the distribution of the dust clouds and, thus, playing an additional role in Betelgeuse's brightness changes. So far, so possible. But how is it that the companion star has not been identified yet? Well, the answer to this question most likely lies in its low mass. According to the scientists' calculations, it weighs only around 1.7 solar masses. Betelgeuse, on the other hand, has nearly 20 solar masses. Moreover, the companion star is likely to orbit its much larger partner closely, at a distance of just 2.43 Betelgeuse radii, to be exact. Therefore, in this arrangement, the companion star is essentially dominated by its more imposing partner. The brightness changes and throbs of Betelgeuse further complicate the task of identifying the companion's traces in the light curve. And even though the chances of detecting the companion star with the present telescopes are, to put it mildly, subtle, the specialists now need to apply for observation time at some of the huge telescopes. In doing so, they hope to uncover further evidence of the celestial companion's presence and potentially even clarify what kind of star we're dealing with here. The subject of what kind of companion you are dealing with under our video is immediately settled. Go ahead, click on approval and subscribe right now to keep up to date from here on out. We'll see you soon.